In this video, we'll learn about the unit circle. The unit circle is a way to find exact values of trig ratios without using a calculator. When we type in our calculator things like sine, cosine, and tangent ratios for different angles, most of the time we are given decimals. However, sometimes we want to find what's known as exact value of a ratio, meaning the exact fraction that the cosine, sine, or tangent ratio represents, not the decimal equivalent. So we can use the unit circle to help us do that. Here's an example of finding exact value. Use the given point on the terminal side of the angle to find the exact value of the trig function. So in this example, we are given the point 5, 12. That is a point that lies on the terminal side of an angle. So the first thing I'm going to do is draw that, or at least sketch it. Here's my coordinate plane. 5, 12 would be 5 to the right and 12 up. So we'll say that's, I don't know, somewhere over here. Now that point lies on the terminal side of the angle. So here would be my angle. I want to find the sine, cosine, and tangent ratio for my angle theta that exists between the x-axis and the terminal side. So the first thing I'm going to do with this is I'm going to draw a leg here to kind of make a right triangle out of my point. Now I know the point is 5, 12. Whoops. So 5 is my x and 12 is my y. So that means to get to this point, 5, 12, I went 5 over and 12 up. So if I'm labeling this right triangle, the base of my right triangle is going to be 5, and the height would be 12. Now I have a right triangle, and I can just use right triangle trigonometry like we did in the last section to find sine, cosine, and tangent. But before I do that, I need to know the hypotenuse, this missing side, because sine and cosine both involve the hypotenuse. So to find the hypotenuse, I'm going to use the Pythagorean theorem. Since I have a right triangle and I know two of the legs, I can use the Pythagorean theorem to find the hypotenuse. So this is going to be 25 plus 144, 169. So C is 13. So now that I know my hypotenuse is 13, I can find sine, cosine, and tangent, because remember, sine is opposite over hypotenuse, so this would be 12 over 13. Cosine would be adjacent over hypotenuse, 5 over 13, and tangent will be opposite over adjacent, or 12 over 5. Now if you look at this triangle, this 5 is my x, this 12 is my y. We call the hypotenuse, when we're talking about trigonometry on a coordinate plane, the hypotenuse is always my r value, or my radius, meaning if I took this point and I drew a circle around it so that the point was on the outside of the circle, this hypotenuse here would represent the radius of the circle. So the hypotenuse is always going to be my r. So this sine, if I wanted to write it in terms of x, y, and r, sine would be y over r, cosine would be x over r, and tangent would be y over x. Those values come into play when we're developing the unit circle. Before we develop our unit circle, we need to know the sine, cosine, and tangent values for our special right triangle. So let's do that. We'll find sine, cosine, and tangent of a 45, 45, 90. So the first thing I'm going to do is I'm going to draw myself a 45, 45, 90. I know that the legs are going to be the same, and I'm just going to pick some numbers. So I'm going to pick 1, because that seems to be the easiest, which means that my hypotenuse would be the square root of 2. So if I wanted to find the sine of 45, that's going to be opposite over hypotenuse. I'd get 1 over radical 2. And now I need to rationalize the denominator, because remember, we can't have an irrational number in the denominator of a fraction. So you multiply by radical 2 over radical 2. This becomes radical 2 over the whole number 2. I'm going to do the same thing for cosine. Well, cosine for my adjacent is still going to be 1 again. So I have 1 over radical 2, which I know from above is equal to radical 2 over 2. And then tangent would be opposite over adjacent, 1 over 1, which is just 1. I can do the same thing for a 30, 60, 90. So I'm going to quick draw well, where's a good spot? I don't know, over here, draw a little one. 30, 60, 90. So this is 30, 60, and here's my 90. We know that the side across from my 30 is 1. My hypotenuse would be 2, and across from the 60 would be radical 3. So sine of 30, opposite over hypotenuse, would be 1/2. Cosine of 30, adjacent over hypotenuse, this would be radical 3 over 2. And tangent of 30, opposite over adjacent, but I want to rationalize this, so this would be radical 3 over times radical 3, which gives me radical 3 over 3. I'm going to do the same thing for 60. Radical 3 over 2, opposite over hypotenuse. Cosine 60, 1/2, that's adjacent over hypotenuse. And tangent of 30, opposite over adjacent, which is just radical 3. No need to rationalize the denominator here because the denominator is just 1. So now I can take all of those values and use them on what's known as the unit circle. The unit circle is a circle on the coordinate plane whose radius is 1. So you'll see here, the origin is the center of my circle, and I go out, this is my radius. That would be the point 1, 0, because my radius is 1 unit long. So the radius of this circle is always going to be 1. That's what makes it the unit circle. So now I can use those values I just found with my special right triangles and fill in the coordinates here. So if you draw the height from this point at 30 degrees, or pi over 6, that means that this is a 30-degree angle here. So now inside my unit circle, I have a special right triangle, a 30, 60, 90 special right triangle. I know the hypotenuse is 1 because the hypotenuse is the radius. So then using my special right triangle values, I can fill in the other parts of the triangle. That would make this 1/2, and this would be radical 3 over 2. So the coordinate points at 30 degrees, or pi over 6 on the unit circle, radical 3 over 2 would be my x, and 1/2 would be my y. So that's my point that exists for 30 degrees on the unit circle. I can do the same thing for all of the other points using special right triangles. If I draw my height here, this gives me a 45, 45, 90 at pi over 4, or 45 degrees. I know my radius is 1, which makes the legs radical 2 over 2. So that is my point here at pi over 4. And now I can do the same thing again at 60 degrees, or pi over 3, draw my height. This is another iteration of the 30, 60, 90, except it's kind of turned a different way. Still my radius is 1, which makes this x 1/2, because that's the side across from my 30. And then my height would be radical 3 over 2. So that's my point here at pi over 6, or pi over 3, sorry, 60 degrees. As you go around, the circle is 360 degrees, so it's not just the values in the first quadrant, but the values repeat for the second, third, and fourth quadrant. Remember, this is the first, second, third, and fourth. The only thing that changes for the different quadrants is the sign. So if I'm looking at this point here, 5 pi over 6, that's still a 30, 60, 90 triangle, except my x now is negative. So when I go to write the point for 5 pi over 6, it's going to be the same as pi over 6, except the x is negative. And that's the same for all of these points. In the third quadrant, if I draw my reference angle here for my triangle, this again is going to be 30, except I have a negative x and also a negative y because I'm going down and to the left. So for all of my points in the third quadrant, both x and y values are going to be negative. And then in the fourth quadrant, I have a positive x but a negative y. So all of the y coordinates for the fourth quadrant are going to be negative. So the values just repeat throughout the circle. It's just a matter of their signs changing. You'll notice these values might seem a little familiar. So for 30 degrees, pi over 6, I got radical 3 over 2 and 1/2. And if we go back to the last screen, radical 3 over 2 and 1/2 are the sine and cosine values for the 30, 60, 90 right triangle. So that tells me that the x coordinate is cosine of my angle and the y is sine of my angle. And that's true for all of these points. If you look at pi over 4, that would be a 45, 45, 90. Radical 2 over 2 and radical 2 over 2 are my sine and cosine values. Well, that's what shows up here. Radical 2 over 2 and radical 2 over 2. So that tells me that the points x comma y are represented by the sine and cosine of each angle. So a unit circle, here's just the definition for you written out, is a circle with radius of 1 unit. For every point x and y on the circle, r equals 1. That's what makes it a unit circle, has 1 radius. And I know the sine of theta is going to be y over r, which if it's on the unit circle, your radius is 1, so the sine value is just y. And then cosine would be x over r, which would be x over 1 on the unit circle, which is just x. If I wanted to find the tangent values, I could just take sine, or I could take the y and divide it by the x, which would also be the sine value over the cosine value. So the coordinates of P can be written as sine theta comma cosine theta for all points on the unit circle. So if you memorize the unit circle, or at least the first quadrant of the unit circle, you don't have to draw out a special right triangle every time to figure it out. So we can summarize all of this values in a table if you don't want to have to draw a circle every time. So I'm going to start with 0 degrees, and then I'm going to fill in all of the special right triangle values, increasing up to 90, because that would be all of the special values in the first quadrant. So I'm also going to write them in radians. This would be 0, this would be pi over 6, this would be pi over 4, pi over 3, and pi over 2. Now to fill in sine and cosine, there is a little pattern here. If you look at just the 30, 60, and the 90, everything is going to be over 2. And then for sine, I'm going to start at 1, then this is radical 2, and this is radical 3. So it really goes like 1, 2, 3. And then for cosine, it's the same thing, except it goes 3, 2, 1. The sine of theta is going to be 0, cosine theta is 1, and then it's backwards for 90. And then the tangent values we found when we were doing the special right triangles. Tangent of 30 was radical 3 over 3. Tangent of 45 was 1. And tangent of 60 was radical 3. The tangent of 0 degrees is undefined, because if you remember from the last slide, we said tangent was cosine. Oh, did I do this backwards? Sorry. Tangent is sine over cosine, so this is an undefined. Sine over cosine 0 over 1 would be 0. And then for 90 degrees, sine over cosine 1 over 0. You can't divide by 0, so that makes this undefined. So you can use this table to help you instead of the unit circle. If we only memorize the first quadrant of the unit circle, though, we do need to be able to figure out the signs for the second, third, and fourth quadrant. So we have this mnemonic device written at the bottom here. All students take classes. That tells you which functions are positive and negative in each of the quadrants. So if you pick a random point here, whatever it is, both the x and y values are going to be positive. So that tells me that all of the trig functions are positive in the first quadrant. If you pick a random point in the second quadrant, this is going to be negative x and a positive y, which means that the cosine is going to be negative, but the sine is going to be positive. So that means that the sine is positive in the second quadrant. That's the S in the students. If you pick a point here, they're both going to be negative. So that means both cosine and sine are negative in the third quadrant, but the tangent is positive because negative over a negative would be positive. And then the C part in classes is cosine because I'd have a positive value, positive x, and a negative y. So that means I have a positive cosine and a negative sine. So in the first quadrant, all trig values are positive. In the second quadrant, the sine values are positive. In the third quadrant, tangent is positive. And in the fourth quadrant, cosine is positive. So let's do some examples, just kind of putting all of that information together. Before that, just a quick definition. If a terminal side of theta lies on either the x or y axis, so if I have an x and a y axis here, that would be any point on any one of these axes. Theta is what's called a quadrantal angle, meaning it lies right on one of the quadrants. We defined theta equals 90 in our chart, but we can do it again here. Sine, cosine, tangent of 90. If you draw the point on the unit circle at 90, that would be up here, or pi over 2, that's going to be the point 0, 1. So my sine value, that's the y coordinate, is 1. My cosine value, that's the x coordinate, that's 0. And then for tangent, I'd have sine over cosine, 1 over 0, which is undefined. For theta equals 180, that would be 180 or pi. That's going to be the point -1, 0. So my sine, cosine, and tangent for 180 can all be derived using that point. Sine of 180, that's my y value, that's 0. Cosine is my y coordinate, or sorry, x coordinate, that's -1. And tangent is y over x, or sine over cosine, which is just 0. So here's how you would evaluate a trig function using either the chart or unit circle for non-quadrantal angles, so angles that are not at 90 or 180 or 270. The first thing you're going to do is find the reference angle. Then evaluate the function for the reference angle, so use your unit circle or exact value chart. And then decide if it's going to be positive or negative based on which quadrant it's in. So find the exact value of 11 pi over 6. 11 pi over 6 is going to be in the fourth quadrant. My reference angle here would be pi over 6. So I want to find the sine of pi over 6. Well, using my exact value chart or my unit circle, I know that the sine of pi over 6 is 1/2. But since this angle, 11 pi over 6, is in the fourth quadrant, the only trig function that's positive in the fourth quadrant is going to be cosine. So since this is sine, I know that the sine of 11 pi over 6 has to be -1/2 because it's in the fourth quadrant. It's not cosine, so that makes it negative. For example B, tangent of 330 degrees, well, that's going to, again, be in the fourth quadrant. My reference angle here would be 30. So I want to really find the tangent of 30, which if I look at my unit circle or exact value chart, the tangent of 30 is radical 3 over 3. Since it's in the fourth quadrant and it's not cosine, whoops, that means that the tangent of 330 is going to be negative radical 3 over 3. And for my last example, cosine of 240, that's going to be in the third quadrant. Little more than 180, but less than 270. My reference angle here would be 60. So I want to find the cosine of 60, which if I look at my unit circle or exact value chart, cosine of 60 is 1/2. Since it's in the third quadrant, the only trig function that's negative in the third quadrant is tangent, and I want the cosine, which means that my value for cosine of 240 is going to be -1/2. Okay, here's a couple more. Evaluate each of the following, find the exact value. So I'm going to do the same thing. I'm going to quick sketch my angle. Negative pi over 3 would be in the fourth quadrant. My reference angle would be positive pi over 3. So I want to find the sine of pi over 3, which is radical 3 over 2. Since it's in the fourth quadrant and it's not cosine, I know that my sine of negative pi over 3 should be negative radical 3 over 2. For B, cosine of 510. So 510 is going to be more than 360. So if I subtract 360 from that, I get that 510 minus 360 degrees is 150. So that means I'm going to go one full revolution around and then another 150 degrees. My reference angle is going to be 30. So I really want the cosine of 30 because that's the cosine of my reference angle. The cosine of 30 is radical 3 over 2, but since it's in the second quadrant, only sine is positive in the second quadrant, which means that my cosine value for 510 is going to be negative radical 3 over 2. For C, tangent of negative 120. So here's where I'm starting. I'm going negative 120, which would be clockwise 120 degrees. My reference angle is going to be 60. So the tangent of 60 is radical 3. Since it's in the third quadrant, I know tangent is positive in the third quadrant, so I don't have to change the sign on this one. So the tangent of negative 120 is actually positive radical 3 because tangent is positive in the third quadrant. And then my last example, cosine 7 pi over 4, that's going to be in the fourth quadrant. Well, a lot in the fourth quadrant today. My reference angle is pi over 4. So cosine of pi over 4 is radical 2 over 2. And since it's in the fourth quadrant and cosine is positive in the fourth quadrant, then I know that the cosine of 7 pi over 4 is going to be the same, positive radical 2 over 2. So hopefully you found this video helpful in finding exact value using a trig chart or the unit circle.